The universe is vast and ancient. It is filled with stars, planets, and galaxies beyond our comprehension. Yet amidst this cosmic grandeur, a profound question echoes through the ages. Where did life come from? How did life arise from non-living matter? This question has captivated philosophers and scientists for millennia. It is a question that speaks to the very core of our existence. From the earliest civilizations, humans have looked up at the stars and wondered about their place in the cosmos. They observed the cycles of day and night, the changing seasons, and the intricate web of life around them. They sought explanations for these wonders. They pondered the origin of it all. The question of life's origin is a mystery that continues to fascinate us. It is a question that pushes the boundaries of our scientific understanding. It forces us to confront the philosophical implications of what it means to be alive. The search for life's origin is a journey that takes us from the smallest atoms to the largest structures in the universe. It is a journey that is both scientific and philosophical, one that challenges us to expand our minds and embrace the unknown. The ancient Greeks were among the first to grapple with the question of life's origin in a systematic way. They were not content with the mythological explanations that had been passed down through generations. They sought natural explanations for the phenomena they observed, looking to the world around them for answers. They laid the foundation for Western philosophy and science, creating a legacy that would influence countless generations. Thinkers like Thales, Anaximenes, and Heraclitus believed that the universe was governed by natural laws, not by the whims of gods. They searched for a fundamental principle or arch from which everything else arose, a concept that would become central to their philosophical inquiries. Thales of Miletus, often regarded as the father of philosophy, believed that water was the fundamental element of the universe. He observed its essential role in sustaining life. He observed that water was essential for all life, noting its presence in plants, animals, and humans alike. He saw how it could take on different forms, from liquid to solid to vapor, demonstrating its versatility and importance. Anaximenes, a student of Thales, proposed that air was the fundamental element. He believed that air was the source of all matter. He argued that air was more ubiquitous than water and could be transformed through rarefaction and condensation, processes that explained the diversity of the natural world. Heraclitus of Ephesus, known for his doctrine of flux, emphasized the ever-changing nature of the cosmos. He saw the universe as a constant state of becoming. He believed that fire was the fundamental element, representing the constant process of transformation and becoming, a symbol of perpetual change. Heraclitus famously said, "Everything flows and nothing abides," capturing the essence of his philosophy. His ideas foreshadowed the dynamic nature of life and the universe itself, a concept that resonates with modern scientific understanding. These early Greek philosophers may not have had the tools of modern science at their disposal, but their ideas were groundbreaking and paved the way for future discoveries. They dared to question the traditional myths and supernatural explanations of their time, seeking instead to understand the world through reason and observation. They set the stage for a more rational and empirical approach to understanding the world, an approach that continues to shape our quest for knowledge today. Aristotle, a student of Plato, made significant contributions to biology and philosophy. His work laid the foundation for many scientific and philosophical inquiries that followed. He was a keen observer of nature, meticulously studying the world around him. He developed a comprehensive system of thought that profoundly influenced Western intellectual history, shaping the way we understand the natural world and our place within it. Central to Aristotle's philosophy was the concept of entelechy, a Greek word meaning having its end within itself. This idea was revolutionary in its time. Aristotle believed that everything in nature has an inherent purpose or goal, a built-in drive to achieve its full potential. This purpose is not imposed from the outside, but is intrinsic to the object or organism itself, guiding its development and behavior. Entelechy is the driving force that propels an organism toward its full potential, ensuring that it becomes what it is meant to be. It is the realization of its inherent form, the actualization of its potential. For example, an acorn has the potential to become an oak tree, a majestic and towering presence in the forest. This potential is not merely a possibility but an actuality that is inherent in the acorn itself, waiting to be realized. The oak tree is the entelechy of the acorn, the fulfillment of its natural purpose. Similarly, a human embryo has the entelechy to develop into a fully formed human being, with all the complexities and capabilities that entails. Aristotle's concept of entelechy provided a framework for understanding the development and behavior of living organisms, offering a lens through which to view the natural world. It suggested that life was not merely a random collection of matter, but rather a purposeful and directed process, with each organism striving to fulfill its inherent potential. While modern science has moved beyond some of Aristotle's specific ideas, his emphasis on the inherent purposefulness of nature continues to resonate with some thinkers today, reminding us of the profound interconnectedness of all life. Section 4: The Clockwork Universe, Descartes, Newton, and the Mechanistic Shift. The Renaissance and the Scientific Revolution marked a significant turning point in our understanding of the natural world, ushering in an era of unprecedented inquiry and discovery. Thinkers like Nicholas Copernicus, Galileo Galilei, and Johannes Kepler challenged the geocentric model of the universe, which placed Earth at the center. They paved the way for a new heliocentric view, where the sun was at the center of the solar system. René Descartes, a French philosopher and mathematician, made significant contributions to this shift in thinking, blending philosophy with rigorous mathematical principles. Descartes is famous for his dictum, cogito ergo sum, I think therefore I am, which emphasized the certainty of self-awareness. He emphasized the power of human reason and the importance of doubting everything that could be doubted, laying the groundwork for modern scientific skepticism. Descartes' philosophy led to a separation between mind and matter, with the material world being seen as a machine governed by mechanical laws, a concept known as Cartesian dualism. Isaac Newton, an English physicist and mathematician, further developed the mechanistic worldview, building on the foundations laid by his predecessors. Newton's laws of motion and universal gravitation provided a comprehensive explanation for the movement of objects on Earth and in the heavens, unifying celestial and terrestrial mechanics. Newton's work suggested that the universe operated like a giant clockwork mechanism, predictable and deterministic in its operations, a view that profoundly influenced subsequent scientific thought. The mechanistic worldview had a profound impact on our understanding of life, influencing not just physics but also biology and other sciences. Living organisms came to be seen as complex machines, their parts interacting according to the laws of physics and chemistry, a perspective that revolutionized biological sciences. This view paved the way for the development of modern biology and medicine, leading to advancements that continue to shape our world today. Section 5: Darwin's Revolution. Life evolves through natural selection. Charles Darwin's theory of evolution by natural selection revolutionized our understanding of life's origin and development. In his seminal work, On the Origin of Species, published in 1859, Darwin argued that all species of life on Earth descended from a common ancestor through a process of gradual modification over vast periods of time. Darwin's theory rests on three main pillars: variation, inheritance, and selection. Variation exists within populations, with individuals exhibiting slight differences in their traits. These traits are heritable, passed down from parents to offspring. In the struggle for existence, individuals with traits that give them a slight advantage in survival and reproduction are more likely to pass on those traits to their offspring. Over time, this process of natural selection leads to the accumulation of favorable traits. New species can arise through the gradual divergence of populations. Darwin's theory provided a naturalistic explanation for the diversity of life on Earth. It connected all living organisms in a grand tree of life. Darwin's theory sparked intense debate and controversy. It challenged the prevailing religious views of creationism. Darwin's ideas continue to shape our understanding of biology and have profound implications for fields such as medicine, agriculture, and conservation. Section 6: From primordial soup to complex cells. The Miller-Urey experiment. In the 1950s, Stanley Miller and Harold Urey conducted a groundbreaking experiment that provided the first experimental evidence for how life's building blocks could have arisen from non-living matter. Miller and Urey simulated the conditions thought to have existed on early Earth, with a reducing atmosphere composed of methane, ammonia, hydrogen, and water vapor. They passed electrical sparks through this mixture to simulate lightning. They found that amino acids, the building blocks of proteins, were produced. This experiment provided support for the primordial soup hypothesis, which posits that life arose in a warm pond or ocean on early Earth. While the exact details of how life arose from non-living matter remain a mystery, the Miller-Urey experiment and subsequent research have provided valuable insights into the chemical evolution that likely preceded the emergence of life, Scientists continue to investigate the conditions and processes that may have led to the formation of the first self-replicating molecules.